Good morning, friends. Welcome to the session of typical problems in geometry. This session is very helpful for the students who are preparing for CAT, ZAT, NMAT as well as SSC, because in this session I will discuss 30 problems. After understanding these questions, you are in a position to attempt any of the typical problem in geometry. I am going to start with the questions one by one. Just pay attention over the questions and side by side try to answer it. Okay. The first statement that I am going to start with here is, it is given that three circles are given. Circle number 1, second one is circle number 2, and third one is circle number 3. All three circles are of equal radius. They are of equal radius. This is equal to 5 centimeter, right? Now based over that, I try to solve some questions. The first statement is, we have to find this area enclosed between it. The question may be also asked in such a way that there are three coins. All coins are touching each other. You have to find the area enclosed, right? When I look at this statement, these are the centers. If I meet the centers, so what I can say, here the radius is equal to 5. It means the total side becomes equal to 10. This side is 10 and this side is 10, right? So I can say that it becomes an equilateral triangle because sides are equal A, B and C. I hope it's clear. If it is equilateral triangle, it means this angle is said to be 60 degree. Now if you have to find the shaded portion, for finding the shaded portion, what you have to do, you are just supposed to take that shaded portion, shaded area is equal to area of the equilateral triangle, area of triangle ABC, right? Subtract 3 into my area of this particular sector. So I can say 3 into my area of sector. That becomes my answer. Okay. Now how I can start to answer my question? Because the side of the equilateral triangle is 10. So I may say area of the triangle is root 3 by 4 into 10 square, that is 100, minus 3 into my area of the sector. You know that area of the sector is pi r square theta by 360. So I make it as pi into my r square. R is 25 into theta 60 upon 360. We have to just solve it. 60 will go on 6, 3 will go on 2. So here I can say 4 will go on 25. So that is 25 root 3 minus 25 upon 25 pi upon 2. That is the required area of the shaded portion that we have to answer. The first question simply states us that we have to find this shaded area. For that, we just meet the centers of the circle. It becomes an equilateral triangle, and we have to just subtract area of the equilateral triangle minus area of the three sectors that we subtracted in such a way, and finally this becomes my answer, that is the shaded area, right? Then I am going to take the second problem in this. That's my problem number 2. We have the three circles of this type, and the radius of the three circles is equal to 10. 1, this is 2, and this is 3, right? Now the question is, we have to find the radius of two circles touching all the three circles. Find the radius of a circle touching three circles, right? Now we have two types of circles here. One that touches them externally, second that touches them internally, right? The first circle that we have, that is this one. We may make a circle drawing, we will draw a circle that is going to touch the three circles in such a way. And second circle may be this one, the circle that is going to touch them in such a way, right? We have to find the radius of these two circles. Suppose we can say this circle is C1 and the radius of this circle is R1, and this circle is C2 and the radius is R2. Here the radius of these three circles are given 5. Meet here, what I can say, it becomes an equilateral triangle. Both side is equal to 10. So I may say that, suppose that the center is A, B and C. So we can say the triangle equilateral ABC side of the triangle is equal to 10 centimeter, right? Now what I can say that if I just draw a circle here, so I can find the radius of the circle. I can easily find the radius of the circle, that is circumcircle. We may say this circumradius of equilateral triangle is a upon root 3, so that would be taken as 10 upon root 3, right? Now if I say this is the center here, so this length is said to be 10 upon root 3. This length is said to be 10 upon root 3. I have to find the radius of the bigger circle, means I have to just add this value. The radius is 5. So what I can say, radius of the circle C1, that is I have taken as R1, so that would be taken as 10 root 3 plus 5, that becomes my answer, right? Similarly, I have to find the radius of the circle that is inside, that is circle radius is R2 and circle is C2. I have to find the radius of this circle. So what I can say, from here to here, that is said to be 10 upon root 3, and this length is 5. So if I have to find this remaining radius, so that would be taken as 10 upon root 3 minus 5, that becomes your answer. Pay attention here what I have done. The three circles are given. We have to find the radius of a circle that touches in such a way as well as in such a way. So what I can say here now, if I have to find the radius of this outside circle, I have taken to be C1 and the radius to be R1. So I can draw a circumcircle to this equilateral triangle. We know that circumradius to the equilateral triangle is a upon root 3 and in radius is a upon 2 root 3. So I can take it as 10 upon root 3, right? If I have to find the radius of the bigger circle, that value 5 we have to take, and my answer is said to be 10 upon root 3 plus 5. Similarly, in this case, if I have to find the radius of this, that would be taken as 10 upon root 3 minus 5, that becomes my answer. I hope it's clear. Then you have next question number 3. It is given that 3 coins are there of equal radius in such a way. We have to tightly tie them. We have to tightly tie them with a rope, right? If the radius of these coins is equal to 5 centimeter, find what length of rope is required. We have to find the length of rope that is required so that they can be tightly tied. Okay. Now when I look at this question, tightly tied means I just meet this, that would be a straight line, then it would be a curve, then I meet this point, that would be a straight line, then I meet this, that would be a straight line, and this is a curve. Now by that rope we can tightly tie it. It is given that the radius of the circles is 5. We have to find what is the length of the rope. How we can take it? We take the center, this is center, this is center, this is center. If I meet this in such a way, this becomes a triangle, equilateral triangle that we know. Similarly, this and this one, right? We know that this angle is 60 degree, being an equilateral triangle. This angle is 90 degree because it is the tangent to the circle with the radius, it makes an angle 90 degree. This angle is also equal to 90 degree. It makes this angle to be 90 and this to be 90, right? This is 60, this is 90. Now what is this left? 90 plus 90, 180 plus 60, 240. It means this angle is equal to 120 degree. Now in order to answer my question, what I basically require? I require this length that I can easily find. This is 5, this is 5, this becomes 10. This also becomes 10, this also becomes 10. I just require this. That is the length of arc for which theta is 120 degree and the radius is 5. So what I can say, my total required rope is 30 plus 1, 2 and 3. 3 into length of arc, that is 2 pi r theta upon 360. That we have to make. Now 120 will go on 3. 3 will be cancelled out. 2 into 5, that is 10 pi. So my answer is equal to 30 plus 10 pi. So here I can say that if I require a tightly rope that will tie all the 3 coins, for that The length of the rope that is required, that is 30 plus 10 pi, that becomes my answer. Sometimes the student may commit a mistake, they take it as a circumference of the circle, that is wrong. In order to get my answer, what process I have to apply? I have to take this length to be 10 and I have to also take the length of the arc, right? For taking the length of arc, we require that angle, and how we can find the angle? This is 60 because being an equilateral triangle. This is 90 and this is 90. That is 180 plus 60, 240. So this angle is 120, and after that we can easily answer our question. That becomes my answer. I hope it's clear. Then we have statement number 4. After this, we have question number 4. Now I am going to change the concept. Till time I am talking about the circles. Now suppose 3 circles are given of equal radius. Suppose the radius given is equal to 5 centimeter. It is given that all 3 coins can be put inside an equilateral triangle in such a way. It is given that this triangle is equilateral triangle. This is A, this is B, this is C, right? And the question is, we have to find what is the side of this equilateral triangle. The question is, if the radius of the circles is 5 centimeter, we have to find out what is the side of equilateral triangle A, B, C. That's our statement, right? Now, in order to answer this question, because it being an equilateral triangle, so we can say this angle is said to be 60 degree. Okay, this is the center of the circle. If I meet this and this one, this angle is 90 degree and this is 5, I can say. Now, in order to answer my question, if I take this here, that is also 5, this is 5. So that value is said to be 10, right? For answering my question, I need this length. If I have this length, that would be the same, because both sides we have the same type. Now we are primarily concerned with how to find this length. We know that from external point to a circle, these two are the tangents. If I meet this, it divides it equally, it means that angle become equal to 30 degree. Now if I take this to be x, so what we know that as per to the trigonometry, perpendicular upon base. So I may say 5 upon x is equal to tangent 30. Tangent 30 is equal to 1 by root 3. So I can say 5 upon x equal to 1 upon root 3 and x equal to 5 root 3. So this length is 5 root 3. This is 10 and this is 5 root 3. So finally I can say the length of the triangle ABC, the side of the triangle ABC is said to be 10 plus 5 root 3 plus 5 root 3, or finally I can say 10 plus 10 root 3. That becomes my answer. That is said to be side of this triangle ABC, that is 10 plus 10 root 3. It becomes your answer. The next problem, that is question number 5 that we have. Suppose there are 6 circles that have been drawn in such a way where the radius of all 6 circles are equal, that is 5, 5 and 5, right? And the statement is, one equilateral triangle is made of ABC. You have to find what is the side of the equilateral triangle. The question is quite similar to earlier one. Only the difference here is we have to take this one. This is 5, this is 10, this is 5. 5 plus 5, 10 and 10, 20. So I may say that the length of this portion is said to be 20. Okay. Now in order to answer my question, I require this length. Suppose this point, suppose I say this is x and this is 5. So I may take it as this angle is 60 degree. Just meet this. This angle becomes equal to 30 degree. So I can say that 5 upon x equal to tangent 30. Tangent 30 would be taken as 1 upon root 3. So 5 upon x equal to 1 upon root 3. Or here I can say x equal to 5 root 3. That's the value of x that you get. Now in order to find the side of the triangle AB, AB would be taken as 5 root 3 and 5 root 3. That would be taken as 10 root 3 plus 20. My answer is said to be, the length of the AB is said to be 10 root 3 plus 20. That becomes my answer. The question may be bigger one. There may be more circles of this type. The idea is very simple. If you have to answer any question based over this type, the way to answer this question is this one. By this way, you can easily answer your statement. Hope that is clear. Next we have statement number 6. It is given that there are 4 circles. Circle number 1, then we have circle number 2, then we have circle number 3, and then we have circle number 4. It is given that all these 4 circles have equal radius. This is equal to 5 centimeter. All these 4 circles have equal radius, that is equal to 5 centimeter. And we have to find the radius of the 2 circles. First, enclosing it inside that one. And second one is, we have to find that point. And after that, first we try to answer this one, right? What process we can apply? If I draw the tangents this way, this way, this way, and in this structure, so it becomes a square. That following structure becomes a square. Now what I can say that we can simply take it as this is A, B, C, D. If the radius is 5, so this is 5, this is 5, 10, and the side of the square is said to be 20. Okay. If side of the square is 20, what we have to finally answer? I have to answer it about the radius of this. So how I can make it? That is 20. If I just meet this one, so this would be 5, 5, 10. That is said to be 10. Okay. Now I have to find the R of this diagonal, that would be equal to, the diagonal is said to be 10 root 3, complete, 10 root 2, this is 5, this is 5. If I subtract 10, then I am getting as 10 root 2 minus 1. That is the diameter of this circle. I have to find the radius, so I can say the radius of this circle is said to be 10 of root 2 minus 1 upon 2, that is said to be 5 times of root 2 minus 1. This is the radius of this circle that we have to answer. I hope it's clear. Similarly, there may be a statement in which we have to find the radius of that circle. Suppose one circle is there and enclosing all the 4 circles. Suppose this shape is given and enclosing all the 4 circles, we have to find the radius of the circle. Okay. Now what process I can apply in this question? I can simply say that here we know that this is equal to 10 root 2. This portion is equal to 5 root 2, because I have to find the radius of this. This is 5 root 2 and this is said to be 5. So I can say the radius of the circle and closing all the 4 circles is 5 root 2 plus 5. That becomes my answer. This is a similar question that I earlier explained you while explaining you the concept of the 3 circles. The same strategy may be applied when we have 4 circles of this type. The one question may be there in which I have to find the radius of the circle that is inside all the 4, and the second is we have to find the radius of the circle that is being made in such a way. For that we have to just make this square, and with that we can easily answer our statement. So that is your question number 6. Then you have statement number 7. When we consider statement number 7, what does it states? It states that there is a square. Inside a square, one circle is drawn touching all the sides of the square. It is given that if radius of the circle is equal to 5 centimeter, so we have to find out there is one square is made at the corner of the circle was 3 points are lying on the square and 1 point is lying on the circumference. In this question it is given that this is a square. For example, if I say this to be A, B, C and D, as per to the question it is given that ABCD is a square. Okay, and based over that we have to find out what is the side of the square. The question is we have to find out what is the side of the square. Now what I can say that in this statement I can say the radius of the circle is 5. It means I can say the whole side of the square is said to be 10, because this is 5, side of the square is said to be 10. Now the side of the square is said to be 10 because it is also a square. It means the diagonal will pass in such a way. Right? Now this is 10, total would be said to be 10 root 2. as to the diagonal of the square. Now I can say that from here to here, this is said to be 10 because that is the diameter of the circle, that is 10. So if I subtract 10 out of it, what I am being left? I am being left with this one and this one. If I divide by 2, so I am being left with AC. So that is the length of AC. Right? Now I have to find the side of the square. Suppose if I say side of the square is equal to x. Right? Then AC, that is the diagonal of the square, that is said to be x root 2. So I can say this x root 2 is equal to 10 of root 2 minus 1 upon 2. Okay. From here I have to find the value of x. It will go on 5. So I may say x equal to 5 root 2 into root 2 minus 1. So this is the side of the square that is being made at this place. I try to understand the question again. It is given that the radius of the circle is 5. If the radius is 5, so we can say side of the square is said to be 10. So this side is 10. From here I can say the diagonal is said to be 10 root 2. Because that is a circle of diameter 10. If I subtract 10 out of here, so I can say this and this sum is equal to 10 root 2 minus 10. Because I am concerned with this particular square, this and this is equal, so I may divide by 2. So here I can say that is the length of AC. Now the question is I have to find the side of the square. If I assume that side of the square is x, from here I can say the diagonal AC is said to be x root 2. Here I can say x root 2 is equal to 10 would be taken as common, root 2 minus 1 upon 2. Just solve it and you can say the value of x is equal to 5 upon root 2 into root 2 minus 1. It becomes your answer. So that is the answer to your question number 7. I hope the idea is clear. Then we have statement number 8. In the statement number 8, instead of making a square, we have a rectangle. For example, one square is there. Inside the square, one circle is being made in such a way that the circle touches all the four sides of the square. Okay, and at this one corner of the square, one rectangle have been made. This is A, B, C and D, where dimension of the rectangles are given. It is given that AD is equal to 10 and CD is equal to 4. It is given that this is 10 and this is 4, right? Now based on this information, we have to find out what is the side of the square. The question is, we have to find out what is the side of the square, or we have to find out what is the radius of the circle, right? Now when we look at this question, earlier question was that it was a square. It was a square, it means if I draw the diagonal of this bigger square that passes through this corner. But in this question it is a rectangle. It means if I draw the diagonal, that will not pass from D. Now in order to answer this question, what process I can apply? I can assume that the radius of the circle is R, or the side would be 2R. Just draw it. We can draw this also, right? Extend it in such a way, extend it in such a way, right? I have assumed that the radius of the circle is equal to R. Okay? If the radius is R, it means this is R, that is R, this is 10, so this portion is said to be R minus 10. Okay? If this is R, this is 4, so I may say this portion is said to be R minus 4, right? And if I meet from the center to the circle to the circumference, this is said to be R. So what I can say here now, it becomes a 90-degree triangle where this is R minus 10 and this is R. So we can apply the Pythagoras here. We may say that R square is equal to R minus 10 square plus R minus 4 whole square, right? Now it's a quadratic equation, we have to find the value of R. We just expand it. This would be R square plus 100 minus 20R plus R square plus 16 minus 8R. Right? This would be cancelled out. Here I can say R square minus 28R plus 116 equal to 0. It's a quadratic equation, we can find the value of R. Right? Because here we have taken a general information from our way. So from that the value of R may be in the under root format, but that it depends on the question. If you have a question of this type, now after solving the value of R, you can easily answer your question. From here you can find the value of R. I hope it's clear. So that is the answer to your question number 8. Next you have statement number 9. Hope it's clear what we have done. Just pay attention again. It's a rectangle. Extend it. This is R. This is 10. This becomes R minus 10. This is R. This is 4. This becomes R minus 4. Now this is R. This is R minus 10. This is R minus 4. Apply the Pythagoras here. After applying the Pythagoras, we can easily find the value of R, and that becomes our answer. That is the answer to your question number 8. The next statement is statement number 9. In the statement number 9, the question is similar, only one concept is being changed. One square is given, right? Inside a square, one circle is being made, touching all the sides of the square. This is given to us, right? Further here, one circle is there that is going to touch the circle as well as the two sides of the square. We have to find out what is the radius of the smaller circle if radius of the bigger circle is equal to 5. We have to find the radius of the smaller circle. Okay. Now, if I look at this question, so what I can say that I can simply state it as in this way. This is 5, this is 5, this is 5, and this is 5, right? Now what I can say, let us assume that the radius of the circle is R. I have taken that the radius of the smaller circle is equal to X. I have assumed that the radius of the smaller circle is equal to X. Okay. It means if I take this to be center, this is X, this is also X. This is X and this is equal to X. Okay. Now it is 5, it is 5. If I just make it as a, right, this is 5, this is 5. So I may say, let us take it as A, B. So I can say AB is said to be 5 root 2. Okay. Then what I can say now, the complete is said to be 5 root 2. Okay. Now further, this portion is equal to, the complete said to be 5 root 2. If I take this to be X, this to be X. So from here to here, that suppose this is O. So I may say OB is said to be X root 2. OB is said to be X root 2. Okay. Now in the answer I have to find, in the answer OB is said to be X root 2. So what I can say that this X root 2, this is X and this is 5. So I may say that that 5 plus this portion is radius, that is X, plus this portion is X root 2. The sum is equal to 5 root 2. Pay attention here what I have done. I have taken that from here to here. The total length is said to be 5 root 2 and that portion is said to be 5. This is said to be X and this is said to be X root 2. So what I can say here now, 5 plus X root 2 is equal to 5 root 2. In the answer I have to find the value of X. So what I can say, take X as common, you will get it as 1 plus root 2 and take the 5 there, you get a 5 into my root 2 minus 1. Okay. Now you have to find the value of X. The value of X is said to be 5 into my root 2 minus 1 upon root 2 plus 1, that is the radius of the smaller circle that we have to find out. Take the question again, what I have done here. It is given that the radius of the circle is 5. If the radius is 5, so I may say this is 5, this is 5. The total length is said to be 5 root 2. After that, because in the question I have to find the radius of the smaller circle. So I have assumed that the radius of the smaller circle is X. If this is X, this is X, so I may say this OB is said to be X root 2. Now this is X root 2, this is X and this is 5. So I may say 5 plus X root 2 is equal to 5 root 2. 5 would be there, so X would be taken as common. We make it as X into 1 plus root 2 is equal to 5 into my root 2 minus 1. So X is taken as 5 into root 2 minus 1 upon root 2 plus 1. That is an answer to my statement. So that is your statement number 9. It's a very important statement because these type of problems are generally asked because in this problem the student generally may be confused. They take it as 5 root 2 and then they are primarily concerned with how to find this value. Because it is very difficult for finding this value. This value may be found by this structure. Then you have statement number 10. When we look at the question number 10, it is given that one quadrant of the circle is given, this angle is 90 degree, right? Or we can say one sector of the circle is given and one circle is being made in such a way that it is going to touch the radiuses as well as the circumference. If the radius, suppose this is OA, it is given that OA is equal to 5 centimeter, we have to find out what is the radius of the inner circle that have to be made, right? Now in order to answer the question, let us assume that the radius of the inner circle is equal to R. So I will take this to be center, just meet it and meet this. So this is R, this is R, so we may say this is said to be R root 2 by applying Pythagoras, and this is said to be R, and complete is said to be 5. So we may say that R root 2 plus R equal to 5, R is taken as common, so you may take it as root 2 plus 1 equal to 5, or finally we can say R equals to 5 upon root 2 plus 1, that is the radius of the circle. Pay attention to the question again, what we have done. One sector of the circle is given, this angle is 90 degree and the radius is equal to 5. Here one circle is being made, we have to find what is the radius of the circle. So what we can say, let us assume that the radius of the circle is R, this is R, this is R, this is said to be R root 2 and this is R. Now we can say total would be R root 2 plus R equal to 5. Just solve it and we can say R is equal to 5 upon root 2 plus 1. That's answer to your question number 10. Now after this question number 10, the next problem that we have, that is statement number 11. Look at the question. What is given that? It is given that one sector of the circle is given, this angle is 90 degree and this is divided into such way such that two semicircles are there. First semicircle, this is the semicircle of equal radius. Similarly here also first semicircle and this is here the second semicircle of equal radius. It is given that if radius of the bigger sector is equal to 4 centimeter, we have to find out what is the area of this shaded portion. We have to find out area of this shaded portion, that we have to find. Right? Now, if I have to answer this question, what process I can think of? From the whole area of the sector, I subtract the area of these 4 semicircles, and because this area is subtracted for twice, once I have to add this area. But our basic problem is how to find out this particular area. Here the problem is how to find out this particular area. Now how to apply this process? It is given that this radius is 4. It means it is 1, this is 1, center this is 1, this is 1, right? Similarly also here this is 1, 1, this is 1 and 1, right? Now what I can say here that I am primarily concerned with how to find this area. If I meet this one, and also if I meet that one with the center of the, right? So this is said to be 1, this is said to be 1. So I have to find this area. If I meet this angle is 90 degree, the radius is 1. If I take the area of the sector and subtract the area of the triangle, so I am being left with this area. Suppose if I say this angle is 90 degree, this is 1 and this is 1. If I take the area of the sector is said to be pi r square into theta upon 360. That is the area of the sector minus. If I subtract the area of this triangle, where base into height, half into base into height, 1 into 1. So I am in a position to get the shaded area that we can find out. In this question, we are primarily concerned with area of this leaf. So that is the twice of this, because this portion is also the same. So I can say area of this leaf is said to be twice of it, right? Here I can say 90 will go on 4 multiplied by 2. So you may take it as pi by 2 plus 1, pi by 2 minus 1. That is said to be area of this leaf. That area is said to be pi by 2 minus 1, right? Now in the answer we have to find out the whole area. So what process we can apply? From the area of this sector, that is said to be pi r square into theta upon 360, right? I will subtract area of these 4 semicircles, 1, 2, 3 and 4. minus 4 into pi. If for this the r is equal to 1, r square, ठीक है, pi r square upon 2. That is the area of the 4 semicircles, because area of a circle is pi r square. Because this is a semicircle, we have to divide by 2. That is 4 into pi upon 2. But when we subtract it 4 times, 1, 2, 3 and 4, it means this portion has been subtracted for twice. But practically we have to subtract it for once. It means once we have to add it. So that is equal to pi by 2 minus 1 that we have to add. Finally what I can say, my answer is said to be 90 will go on 4, 4 will go on 4. So that is said to be 4 pi minus 2 pi plus pi by 2 minus 1. Okay. Then 4 pi minus 2 pi is 2 pi. 2 pi plus pi by 2 is 5 pi by 2 minus 1. So that is the required area of the shaded portion that we have to find. In this question we have understood this particular concept, how to find the area of this leaf. If you want to find the area of this leaf, we have just met this 1 and 1. So that becomes a square. This angle is 90 degree. If this angle is 90 degree, so we may take the area of this sector, then subtract the area of the triangle. We are in a position to find the 1/2 of the leaf. If I make it twice, we are in a position to find the whole leaf. That value will be that one. And then I can say from the area of the whole sector, I may subtract these 1, 2 and 3 and I am in a position to get my answer. Then we have statement number 12. In the statement number 12, it is given that we have one circle and two semicircles in such a way right. In this question, that is given in such a way, because the question is given as we have two semicircles and one semicircle. One circle has to be drawn that touches these two circles externally and this circle internally. It is given that if radius of the semicircle, this bigger one, the bigger one semicircle is 4 centimeter, that I can say this is O and A. It is given that OA is equal to 4 centimeter. We have to find out what is the radius of this circle. Okay. Now in order to answer this question, because these two are the semicircle, this is 4. So I may say this is 2 and this is said to be 2. Okay. The next step what I can say, I have to find the radius of this circle. Suppose the center of the circle is O and I have assumed that the radius of the circle is said to be x. So what I can say, I may say it as this to be x, this is 2, I will draw this, the total is said to be 4, this portion is x. So this from here to here, this portion is said to be 4 minus x and this is said to be 2. So from here what we can infer that, I can simply say that this is the radius of the semicircle, the total is 4, this portion is x. So this is said to be 4 minus x, this is x, this is 2, so I may say this is said to be x plus 2 and this is said to be 2. So I may apply the Pythagoras here because that angle is 90 degree, it is said to be the tangent. So I may say that 4 minus x whole square plus 2 square is said to be x plus 2 whole square. Okay. Now open it, that is 16 plus x square minus 8x plus 4 equal to x square plus 4 plus 4x. This will be cancelled out, 8x will go there, that makes me 12x equal to 16 plus 4, that is 16 plus 4 20 minus 4, that is 16. Here I can say x equal to 16 by 12, or you may take it as 4 by 3. So I can say that the radius of this circle that is going to touch these two circles externally and this circle internally is said to be 4 upon 3. That becomes your answer. I hope the idea is clear. So that is your statement number 11, by which we just understood this question was earlier asked in the CAT examination, where you have to find the radius of this circle. So by this strategy we can easily find the radius of this circle. Then you have statement number 12. What is given to you? It is given that one equilateral triangle is there, ABC. One circumcircle of the triangle is made, in such a way. You have to find what is the radius of the circle, that circle, if a side of the equilateral triangle is said to be 10 centimeter. It is given that the side of the equilateral triangle is said to be 10 centimeter. We have to find the radius of this circle. Now, if I try to answer this question, what process I can apply? I may take that to be complete height. Suppose this is A, this is B, this is C. This is said to be D, right? That is said to be D. And this is said to be O, that is the circumcenter of the equilateral triangle. If I take this to point to be E, the first step I can say, because the side of the equilateral triangle is 10 centimeter, so I can find out the circumradius of the equilateral triangle. The formula for circumradius is said to be A upon root 3, that is 10 upon root 3, which would be equal to OE. That we can take, right? Then what I further require? I require this DE. I have to make the half of it, that is my answer. For that I require this AD, right? I require this AD. So what I can say that this AD is said to be in radius, because in equilateral triangle, this is the circumradius and this is the in radius, and in radius is said to be A upon 2 root 3, so that is said to be 10 upon 2 root 3. It means if I have to find DE, so DE would be taken as 10 upon root 3 minus 10 upon 2 root 3. Right? So here I may take my LCM to be 2 root 3. That is said to be 20 root 3 minus 10. It is said to be 20 minus 10. And finally I can say it as 5 upon root 3. So there D is said to be 5 upon root 3. We have to find the radius. So it is a half of it. So we can say the radius of this is equal to 5 upon root 3 into 1 by 2. So I can say the required radius is said to be 5 upon 2 root 3. It becomes an answer to my statement. That's my answer, 5 upon 2 root 3. After statement number 12, next we have statement number 13. What this question talks about, it is given that there is one triangle is given. This point is A, B, C. 3 points are given D, E and F. It is given that ratio of BD ratio DC, that is said to be 2:1. Ratio of AE ratio EC, that is said to be 3:2. And AF is to FB, this ratio is 2:3. Right? Based over this, the question is, we have to find out what is the ratio of area of the triangle DEF with the area of the triangle ABC. The question is, we have to find out the ratio of area of the triangle DEF with the area of the triangle ABC. Now, in order to get my answer, what process I can apply? I have to start to find the areas of this with the total. First, I will just start to answer it. How to find area of the triangle BDF with the area of the triangle ABC. Area of the triangle BDF upon area of the triangle ABC. Right? We know that the area of the triangle is half into product of the two sides into side of angle between them. Right? Here I can say this ratio is BD is to DC is 2:1. I may take it as 2x is to x. Similarly, AE is to EC is 3. I may take it as 3y is to 2y. And similarly, AF is to FB is 2 is to 3. I may take it as 2z is to 3z. Right? Now, if I take the area of the triangle BDF, it means I may take it as half into product of the side, means 3z into 2x into sine of angle between them, that would be taken as sine B, upon I will take the area of the triangle ABC, that would be taken as half into this side 2x plus x, that is said to be 3x, into 2z plus 3z, that is said to be 5z, into sine B. Right? Now from here I can say this will be cancelled out, x will be cancelled out, z will be cancelled out, sine B will be cancelled out. So that is said to be 6 upon 15. Right? So I may say that area of this triangle with the total is 6 by 15. So what concept we can apply here now? multiply 3 into 2 6 upon 3 into 5, that is 15. From that I can say area of the DCE with the total 2 into 1, that is 2 upon, that is 3 into 5 15. Similarly I can also find the area of triangle AFE with the total, that would be taken as 2 into 3, that is said to be 6 upon, that is 5 into 5 25. Right, so here I can say that the area of the triangle AFE, BDF as well as CDF with the total. Right, now we know that the total area, that is the sum of all the 3 by ABC is equal to 1. If I have to find this one area, what I can say that that DEF is said to be 1 minus, if I take the total area to be 1, so that would be taken as 1 minus 6 upon 15 minus 6 upon 25 minus 2 upon 15. Right, so here we can say LCM is said to be 75, that is 75. I can say that is 75 minus 15 5 30 minus 3 6 18 minus 5 2 is 10. Okay, now this is 30 plus 10 40, 40 plus 18 58, 75 minus 58, that is 17 upon 75. So I can say that the ratio of the area of this triangle with the total is 17 upon 75. By this we are in a position to get our answer. Now for answering these type of questions, this process is very simple. We have to just take as a fractional value, means I can take area of this triangle with the total. Concept is very easy. Either we have to apply this formula or you may go by this way. 2 into 3 6 upon 3 into 5 15, that is taken as 6 upon 15. Similarly we can find all the 3 and the total is 1, so I will subtract 1 from the 3. So I may say that the area of the triangle DEF 17 by 75 upon 1. So finally ratio is said to be 17 upon 75. That becomes my answer. Then we have statement number 14. After this we have question number 14. What this question talks about? It simply states as that one square is given. This is A, B, C and D. It is further taken that on side AB one equilateral triangle is formed. That point is E. Okay. Then from E one perpendicular is drawn and E is met with C. We have to find this angle. Suppose that is F. We have to find the angle FEC. The question is we have to find the angle FEC. Right. Now what process we have to apply in order to answer this question? The total is a square and this is an equilateral triangle, right? So here I can say this angle is 60 degree being an equilateral triangle and this angle is said to be 30 degree because it was a square, total is 90 degree. So I can say this angle is 30 degree. Now after that I can say because it is an equilateral triangle means all three sides are equal and it's a square means this side is equal to this one. So here I can say side BE is equal to side BC. These two sides are equal. Hence these two angles will also be equal. Means I will say that this angle is equal to this particular angle. Now I can say in triangle BCE, the sum of all three angles is equal to 180 degree. This angle is 30. It means sum of these two remaining angles is equal to 150. Because these two sides are equal, hence these two angles are also equal. So I may say this angle is said to be 75 and this angle is also said to be 75. Right. Now if this is 75, this is 90, it means this angle left is equal to 15 degree. That becomes my answer. Pay attention here what I have done. One square is given here and we know that inside a square there is an equilateral triangle with the same base. This is 60, this is 30. Now because these two sides are equal, it means we can say that the sum of the angles is 150. Both are equal, 75 and 75. Now this is 75, this is 90. It means that is equal to 15. So here I can say, we can say that angle FEC is equal to 15 degree. That becomes your answer. It's a very important statement in paper pencil mode. In the year 2005-2006, 2 times this question have been asked in your final examination of CAT. Then after that you have statement number 15 here. It is given that if a square plus b square plus c square equal to ab plus bc plus CA, right? And ABC are the sides of the triangle. ABC are sides of triangle. We have to find out about the triangle formed. What type of triangle is being formed, whether it's an equilateral triangle or isosceles triangle or it's a right angle triangle, right? What I can say, if I make the twice of this, so I may take it as 2a square plus 2b square plus 2c square equals to 2ab plus 2bc plus 2ca, right? Now we take these sides here. I will break in two parts. First I take a square plus b square minus 2ab, one pair I have made. Second pair I can make b square plus c square minus 2bc, and third pair I can make, that is a square plus c square minus 2ac. The three pairs I have made, right? Now that is equal to 0 because all values have come this side. Now what I can say, this would be taken as a minus b whole square. This is taken as b minus c whole square. This is taken as c minus a whole square, that is equal to 0. Because here the powers of all values are 2. The power is even, all values are positive. And we know that when some of the values are positive, that can only be possible when all these are equal to 0. It means a equal to b, b equal to c. Hence we can say, if ABC are the sides of the triangle, we can say the triangle such formed is said to be equilateral triangle. So I can say that such type of triangle that we have to form, that is an equilateral triangle. That's your statement number 15. Next, one more problem is there, statement number 16. It is given that one right angle triangle is there in such a way. This angle is 90 degree and this side is 15 and this side is 20. One perpendicular is drawn from here, right? And two circles are made here. One is touching all the three sides internally in circle of this triangle. Second is in circle of this particular triangle, right? If C1 and C2 are the centers of these two triangles, so we have to find out what is the distance between the centers. C1, C2 are the centers of these two triangles. These two circles, we have to find out what is the length of C1, C2. That's our statement. Okay. Now when I look at this question, how we can answer it? Suppose the radius is this equal to small r and this radius is equal to capital R. Right? Now if I meet these two, that length I have to find out. Okay. And what I can say that this is the radius of the first circle and here that is the R of the second circle. The total we can find out easily. This total value we can find out via help of the R. Suppose if I say this point is A, so I may say that this angle is 90 degree and we have to just find C2A. If I take the radius of the smaller circle is R1 and the radius of this circle is R2. So I can say that C2A is equal to R2 minus R1, right? And this C1A, this is said to be R1 plus R2. By applying Pythagoras, I can find C1, C2. That is our scheme to answer the question. Now the first point is, for finding the answer, I need R1 and R2. How to find it? Here I can say this is 15, this is 20. By Pythagoras, this would be 25. That is 400 plus 225, 625, that is 25. Okay. Now first I need this height. Right? So I can just compare that structure. How I can make area of this two triangle is said to be half into base into height, 20 into 15. This is same as to half into 25 into height. Height may be taken as, suppose that is C and that is D. So I may say that is CD. Okay, this would be cancelled out. 5 will go on 5, will go on 4, 5 will go on 3. So I may say this CD is equal to 12. So I can say that this height is equal to 12. Now after Pythagoras I can find this R1D, that is 225 minus 144. That is 81. So I may say this side is said to be 9 and this is said to be 16. Okay. Now after that we have to find this R1. We know that the in radius formula is, we know that R into S is equal to area of the triangle. That was the formula for in radius. R1 we have to find out. R1 into S, semi-perimeter. 15 plus 12, 27 and 9, 36 by 2. That is 18 equal to area of the triangle. Half into base into height. Half into 9 into 12. Okay. 9 will go on 2. 2 will go on 6. 2 will go on 3. So I may say R1 is equal to 3. Okay. In a similar way, I can also find the R2. Now, what is the process to find the R2? Now, I will take this triangle CD, that triangle. In that, I can say that that R2 into semi-perimeter. The semi-perimeter is said to be 16 plus 12, 28 plus 20. 48, that is 24, equals to area of the triangle. The area of the triangle is said to be half into base into height. 16 into 12. 12 will go on 2, 2 will go on 8, 2 will go on 4. So I may say this R2 is said to be 4, right? Now this is 3 and this is 4. It means that portion would be 1 and this is said to be 7. We have to find the distance of C1, C2. By applying Pythagoras, we can say that is 7 square 49 plus 1. My answer is said to be root 50. That is the distance of these two centers, C1 and C2. That becomes my answer. Pay attention here what I have done in this question. I have just taken this statement in such a way that first of all I just told you how to answer the question. Then we need the radius of this incircle. Also we need the radius of this incircle, right? For that we have this particular concept, R into S is equal to area of the triangle. So first of all we have just found this height CD by comparing the area of this triangle, one by half into base into height and by this one half into base into height. So we can find CD. Once you have the CD with you, then you can find this base, okay, and then by applying the formula of radius into semicircle is R into semi-perimeter is equal to area of the triangle for in radius, we can find our answer. I hope the idea is clear. So by this structure we are in a position to get our answer. That is the answer to our statement number 16.